All right, so we're doing solving equations with variables in the denominator today. So recall, when solving algebraic equations, we should always work toward getting the variable upstairs or into the numerator, and on its own using, I guess, opposite or inverse operations. So what that means is if it is an addition problem an addition operation that appears in the equation, you do the opposite of addition, which is subtraction. If there's a division, you do the opposite of that to find the variable. So our best strategy when solving algebraic equations is to work backwards through BEDMAS. So we're going to do SAMDEB. SAMDEB. Okay. In the examples that follow, the variable will sometimes appear in the denominator. The easiest way to bring the variable up to the numerator is to multiply both sides of the equation by the variable. So we'll see how that goes with a few examples here. Starting with number 1. 93 divided by x equals 3. So in other words, 93 divided by something equals 3. You could probably do that with inspection. You might do 31. 31 divided by something. So let's check. So the other way we can do it is multiply both sides by the variable, because it's currently in the denominator. We need to bring it upstairs and get it on its own. So on the left, x divided by itself is just 1. And what remains then on the left is 93. And on the right, we have 3x. Okay, and now we have something kind of familiar looking now. The variable is upstairs or in the numerator, so that's great. And we need to get rid of this 3. So we do 3 times x. The opposite of multiplying by 3 is dividing by 3. We do that to both sides to get rid of the 3 on the right. And 93 divided by 3 is 31, hopefully. So we can test that. Stick 31 into the original equation. So if I go 93 divided by 31, which is my value I found for x, that's indeed 3. That equals the right side, so we're good. Okay, on to the next one. Again, variable in the denominator. We need to get it into the numerator, so multiply both sides by the variable. And we know how to multiply fractions, so that should be easy enough. We just multiply straight across the top and straight across the bottom. So if you wanted to write this more fully, you would end up with negative 42x divided by x, and x divided by itself is just 1. Anything divided by itself is 1, so the result there is negative 42. So that's the left side. And the right side is going to be 4x. So now we're in familiar territory. We've got negative 42 equals 4x. So it's 4 times x, the opposite of multiplying by 4, divide by 4 on both sides. So 4 fits into 40 10 times, and 4 fits into 2 1/2. So 4 into 42 is going to be 10.5 and negative 10.5. All right, the next two are fairly similar. Again, we've got the variable in the denominator. We need to bring it into the numerator and then eventually get it on its own. So 3.6 over 1 is the same as 3.6. So next we get 3.6x equals negative 1.2. Okay, and 3.6 times x, we got to get rid of this 3.6. So the opposite of multiplying by 3.6 is dividing by 3.6. And 3.6 divided by itself on the left is 1. And 1.2 divided by 3.6 is 1/3. So you can try that out. I'm just going to exclude the negative just for simplicity, and I'll put the negative in later. So 0.3 repeating, 1/3. So that is -1/3. Okay, on to D. Very similar. Get the variable upstairs or into the numerator, so multiply both sides by x over 1. On the left, we get -7x, and on the right, we just have 3.5 remaining. I need to get rid of the -7. So I want to get the variable on its own. So we divide both sides by -7. On the left, only an x remains. So we have x equals something. 3.5 times by 2 is 7. So this is 1 part, that's 2 parts. So that would be -1/2. Okay, and again, you can test this out if you want in your calculator. If you're unsure of your answer, the left side should equal the right side. So if I get the variable being -1/2, I can type 3.5 divided by -1/2. So decimal equivalent is 0.5. That's equal to -7. That's the same as the left side. So answer is good. Okay. Similar numbers, but slightly different problem here. This one, the variable is already in the numerator, so we do not need to multiply both sides by the variable. The only thing we need to do is get rid of this 3.5 in the denominator. So in order to do that, we do the opposite of dividing by 3.5, which is multiplying by 3.5. So we do that to both sides, 3.5 over 1, multiplying both sides. 7 times 3.5, 7 times 3.5 is 24.5. So we get -24.5 equals x. So 3.5 divided by itself on the right is 1. We're left with x. And a positive times a negative is a negative, so hence the negative in the 24.5. Okay, just a few more. F. So x over 3 plus 2/3 equals 1/6. So the variable is currently in the numerator, so I don't need to multiply everything by the variable. It's already upstairs. I need to work to get the variable on its own. So if I'm working through SAMDEB, again, that's not like an absolute rule, it's just a good rule of thumb, generally helpful. I want to get rid of this first. So adding 2/3, the opposite of adding 2/3 is subtracting 2/3. So I do that to both sides. Simple enough. On the left, 2/3 minus itself is 0, so all that remains on the left is x over 3. And we get to do a little bit of fraction operation on the right side. So we have 1/6 minus 2/3. I need to have the denominator to be the same before I can add these. So the lowest common multiple of 6 and 3 is 6. So I can keep 1/6 the same, and I can change 2/3 into an equivalent fraction over 6. In order for me to do that, I can multiply the top and the bottom by 2. So 3 by 2 gives 6, and 2 by 2 gives 4. So the equivalent fraction of 2/3 is 4/6. Now the denominators are the same, so I keep them the same. And 1 subtract 4 on the top is -3. So -3/6, which I can reduce to -1/2. So a little bit of a side procedure there. -1/2 is the result on the right side. Okay, and we're a bit closer, so at least I got rid of the 2/3. And now I got to get rid of the 3. So to get x fully on its own, I need to get rid of the 3. So the opposite of dividing by 3 is multiplying by 3. I do that to both sides. 3 times x over 3 is just x. So the left just becomes x, and -1 times 3 is -3, and 2 times 1 is 2. So the answer there is -3/2. Okay. Generally a good idea to check your answer too. So I'm going to put -3/2 in for x. Decimal equivalent is -1.5 if that makes it easier for you to type in your calculator. So I am going to evaluate the left side, so the left-hand side, and that should equal the right-hand side. So where'd that calculator go? Here we go. So -1.5, -1.5 divided by 3. So that's that. And then I'm going to add 2/3 to that result, and that should give me 1/6, hopefully. And it does, so -3/2 is the correct answer. Okay, a few more remaining. Okay, so I just need to write these down. G, 2/5 x plus 1/2. 2/5 x plus 1/2 equals 1/10. So work through SAM/DEB. Do the addition subtractions first. So I'm going to take care of this positive 1/2 first. Subtract 1/2 from both sides. 1/2 minus itself is 0. So all that remains on the left is 2/5 x. And then I need to do some fraction work on the right. So 1/10 minus 1/2. Lowest common denominator there is 10. So if I multiply top and bottom of this fraction by 5, I get 5/10. That's equivalent to 1/2. Denominators are now the same. That's great. So I keep that the same, and I do 1 minus 5 up top, which is -4/10. I can reduce that, both divisible by 2, so that would be equivalent to -2/5. So -2/5. And we're getting there. So that's the right side. And now I need to, again, get x on its own. There's a 2/5 there. I could do this in one step and multiply both sides by 5/2, and that would get x on its own right away. Or I can take care of the 5 in the denominator first. So I can just multiply both sides by 5/1. So in the next step, I will get 10x/5. So 10x divided by 5 is 2x. So essentially these two divide out. 5 divided by 5 is 1. And on the right side, I get -10/5, which would be -2. So essentially those divide out. And simple enough remaining. 2x equals -2. Divide both sides by +2. And I get x equals -1. So x equals -1. All right, and I think we got one more to go. 2 minus x/4 equals 3/8. 2 minus x/4 equals 3/8. Okay, so I've already got the x's on the left side. I've got another number over here on the left as well. So I need to make a choice. I need to either bring all the letters to the left or bring all the letters to the right. Since they're already on the left side, I'll just go ahead and move the numbers to the right side. So to get rid of the 2, I'm going to subtract 2 from both sides. 2 minus itself on the left is 0. So that's just negative x over 4 remaining. And on the right, we've got 3/8 minus 2. So we got a little bit of fraction work to do. 3/8 minus 2 over 1. So if I want to turn that into common denominator, I can write them both over 8. So I need to multiply top and bottom of the second number by something to get the bottom to be an 8. What times 1 gives 8? That's 8. So I multiply top by 8 and the bottom by 8. So 16 over 8 is equivalent to 2 over 1. And the result with that fraction, keep the denominator the same, 3 minus 16. You could think of it as 16 minus 3 if you prefer, and then just make sure to swap the sign. So that's 13, and then you keep the sign of the larger, which is a negative. So 3 minus 16 is negative 13. So negative 13. I really hope I got that right. Okay, so negative 13 over 8, and then basically one step remaining. Let's do. So I need to multiply both sides by, I can multiply both sides by negative 4 over 1, because there's a negative in front. Negative 4. If you prefer, you can multiply both sides by 4 and then divide both sides by negative 1, but you can do it kind of in one step. So negative 4 divided by negative 4, right? Because I can write negative x over 4 as x over negative 4, so I'm just treating this as x over negative 4. Okay. So the left side will be positive x, and the right side will be negative 13 over 2, which you can confirm if you like, if you have access to a calculator. Negative 13 over 8 times negative 4, should be positive, so that would be positive 13 over 2. Yeah, negative times negative is positive. Okay, your assignment for today, page 281, number 7, 8, 16, and 21. And might be a good idea to start on the mid-unit review, because we will be having a quiz upon our return after the break. Take care.